Ladies and gentlemen, welcome to another edition of Tech in 10 with Steve. Today I'm going to be going over overclocking and be basically doing my overclocking guide and going over all the overclocking features on the Z97X-SOC Force. So right now I entered the BIOS and the first thing it's going to ask me is the system language. So there are all these languages. You just select one where it says welcome and you press enter. Now this is the startup guide. This is very easy to use. So you want to go to startup options. We can settle this later. I'll go over that in my BIOS guide. But just press F2 and you can go to the older BIOS, or press F2 again and it should take me to the Smart Tweak. Now Smart Tweak is different than it was before. Before all the features were there. Now I only have frequency, memory, voltage, miscellaneous, home, save and exit. Everything else is in the older BIOS or in the quick start menu that first appears. So we can zoom in a little bit more so you can see some of these features. So base clock is over here. Now these are automatic overclock. So upgrade CPU and memory, 20%, 100%, all that kind of stuff. CPU base clock is on auto. I can press an M and go to manual. Then I have control over the host clock frequency. I can set that whatever I want. Base clock ratio. And then I can also do spread spectrum control, 0.1% to 0.5%. So you really just want to leave this on auto. You don't even want spread spectrum enabled when you're overclocking base clock. So we don't need to mess with that. We can just set auto on that. Processor graphics clock, we're not messing with that. CPU upgrade is an automatic CPU overclock, anywhere from 4.3 to 4.7 gigahertz. CPU clock ratio, let's do a 4.5 gigahertz dirty overclock. So I'm going to go to 45x, just type in 45, or you can use a slider. The mouse moves really easily in the BIOS. It's really cool that it moves so easily. I can actually change this on the fly. So if I go to on and then I hit apply, it'll change the thing on the fly. But we're not messing with that. Let's also enable XMP. Okay, advanced CPU core features, KOC unlocks multipliers that weren't there before. Then we have CPU PLL selection here, so we're not going to mess with that either. So I'm just going to go uncore. I'm going to just set 40x on the uncore, 4 gigahertz straight. Turbo boost I can just leave auto. We're not going to mess with any of this, but I'm going to disable all the power saving states. So I just press page down to disable. Or you can just select it and say disable, or page up, or whatever you want to do, plus minus. You can also click it and do all that kind of stuff, and then you can scroll up and down. Memory, I already enabled XMP profile 1, should take us to 2800 megahertz. Voltage, so I'm just going to change a few things here. I'm going to change LLC to extreme. I'm going to change PWM phase control to extreme performance. CPU core voltage, VRN external override, I'm going to set this to 2.2 volts. CPU vCore, I'm going to set 1.275 volts. Ring voltage 1.1 volts, and I'm not going to touch DRAM. I think XMP will take care of that. Now I can just press F10 and it'll save and exit. However, I've actually saved this profile in tag. Now I can go over here and save profiles. So tag is number 8 and it has tag written right next to it. So I've already made this profile in tag for 45x. We're not going to load that right now, but later on I'll show you how tag works after we clear all this stuff out. Anyway, so we're going to save and exit. And now the system will boot. You can see the vCore is going to push up to 1.283 volts. And now let's take a look at some of the system stuff going on here. So I have the voltage read points in there, so I can read real voltage because CPU-Z is lying nowadays. It just shows a vid. I have a bunch of buttons over here. I'll go over them in their order. Reset button right next to that little white button that's reset is a few black buttons. These control other stuff. So this is memory safe, direct to BIOS. I'll show you that soon. Settings lock takes you to last best settings. Memory safe will take you to the memory settings. This is dual BIOS disable switch right here. It'll disable the dual BIOS mechanism. Then you have the dual BIOS switch between main and backup BIOS right there. And then we have the trigger switch, which I'll also show you. Power button, of course, minus multiplier, plus multiplier, minus base clock, plus base clock, gear button. And then over here we have a turbo button, a tag button, and a OC ignition. We also have DIM and PCIe disable switches. So I don't know if you can see both sets from that angle. Maybe you can see from this angle a little better. Okay, and you can see the HDD LED keeps blinking. Now this shows me HDD activity, which is really important for certain benchmarks. We also have one SATA or a couple drives in there. CBAT button will totally clear out all the stuff memory. It's basically like removing the battery and clearing the CMOS. But there's also a clear CMOS button located next to these switches over here. this over here is clear CMOS, that little black one all by itself. This is also OC Connect right here. Now OC Connect will allow me to hook in any USB device there, so that's pretty cool. So right now I'm going to show you some of these, what some of these buttons can do in Windows in real time. So I'm going to zoom in a little bit because we're going to be using CPU-Z, and I want to get really close up in there so you can definitely see what's going on with CPU-Z. Okay, so I'm going to zoom up a little bit, and I'm going to show you real-time overclocking with CPU-Z. Okay, so 45x right now. Now I'm going to press plus on the multiplier, okay? So when I press plus on the multiplier, or I'm going to press minus, it should go to 44x, right? 44x. Now I'm going to press plus, it'll go back to 45. Now the base clock, I can go up and down 1 megahertz, so I'm going to go down first, so I go 99. I'm going to press up and go back to 100. Oh, I pressed, yeah. So there's also a gear button. So I'm going to engage gear right now. And gear allows me to change the base clock in more fine increments. So I'm going to press plus and it should go to 100.1, 2. So it goes up between 1 and 3, 0.1, 0.3 megahertz. So I'm press it one more time. There I go, 0.3. One more time. Should go to 0.6 now, really slowly. Okay. So yeah, it's more coarse. I'm going to go back down to 100. Press it a few times. So this is, you can use this or you can use GTL to change stuff in Windows, which is pretty handy, right? So I'm going to pull up GTL right now and show you how GTL works and some of the cool things GTL can do. So we're outside. GTL just needs to be launched. No, you don't have to run as an administrator or anything like that. So GTL works much in the same way as the buttons, except it's a piece of software from Gigabyte. So these are my voltages. And it says 1.28 right here, right, in real voltage from the read point. But look at CPU-Z, it's showing 1.272, and it's showing that because that's the vid in there. Now the vid is just this barely changes, it's incorrect. So cores, I can go to like 46x, hit that, hit apply, and now I'm at 46x right here. We can go back to 45x, and now let's change the base clock to 101. Apply. 101 and 45x, right? So that's how that works, and we can also change uncore. So I've overclocked the uncore to, well, let me apply 100 megahertz back, so everything's back. You see the memory OC is there. The XMP engaged 1400, which times 2 is 2800. Correct latencies and command rate. And Northbridge frequency is locked at 40x, which is 4 gigahertz. Now I can change this on the fly as well, so 41x. And so I went to 4099. So that's pretty cool. Everything on GTL works. These are the PWM switch rates. You don't really need to mess with these, but maybe you can experiment. The range is between 300 and 400. This is VCC in, the input voltage, V core. Like let's say I want to increase this to 1.3 volts. So I have 1.3. Hit apply. And now this goes up to 1.302, like that. CPU-Z reads 1.301. So right now it's on target, but usually it's not. And then we have a couple other features. DRAM sync. Now this will, if I uncheck this, then I can set my DDR termination voltage out of sync with the DDR voltage. But otherwise, it's going to set this at 1/2 DDR voltage, which is what it should do. PCH core, VDDIO, VIOA, analog and digital, system agent voltage, ring voltage, all that good stuff is there. Now we also have hotkeys. So hotkey 1 will enable that kind of stuff. So you set these hotkeys independently. So you set a profile, and you can change these hotkeys and go ahead and use them. So the hotkeys are pretty good in case in the middle of a benchmark you want to go back and forth between different profiles, like maybe you just want to change the profile, change the voltages, stuff like that on the fly in the middle of a benchmark. Then you can hit like Control and 1, stuff like that, and the hotkeys will apply that profile in real time. So anything GTL can do, you change the profile up, and that's what's up. So, and you save the profile here. Anyway, so I'm going to exit out of GTL right now, and I'm going to show you direct to BIOS right now, and then I'm going to show you OC ignition and tag. So right now let's go back here, and direct to BIOS is the middle button here. So I'm going to press this. That's all I had to do. Now when we restart the system, it is going to take me directly into the BIOS. not touching anything, and you see it went into the BIOS by itself, which is pretty cool, right? So I didn't change my startup screen. I can if I want to. Anyways, I'm going to load optimized defaults, so there's no overclock on here at all. Right now you can see the overclock is still applied with the vCore. F7, load optimized defaults, yes. Now F10, and that saves and exits. Okay, so that is saved and exited. And actually, I'm going to let that save and exit and then go back into the BIOS and show you everything as default right now. So default vCore right, it changed the vCore back to default vid. So I'm back at 3900, all that kind of stuff, right? The default stuff. Now, they're asking about the resolution. So anyways, let's go back to the board. So I'm going to shut it down right now and show you OC ignition. So OC ignition will basically power the system up. So I just engage OC ignition button right here. Just press it in once. It's a toggle switch. So right now if I press the power button, it's not going to actually start the power, but I'm also going to engage tag. So I just engaged tag. Now tag, remember we had that 4.5 gigahertz profile set. So that profile should be engaged right now and should be what's up. So I'm going to press it once, and this is just OC ignition working. See, nothing comes up on the post screen. It's not supposed to, but you see everything powered up. The light came on for the BIOSes. I can hear my hard drive spinning up. The button lights up. Fans are working. You can hear it, or you can just see the fan working, right? And the system is off. You can see vCore is also 0, right? Basically 3.7 millivolts, just residual charge. So now I'm going to press power button one more time, and as you see, the system is powered up. And it's going to cycle once or twice, and it's going to give me my overclock. Now it seems like it's going to the BIOS, but it's not. Now watch the voltage. There we go, 1.282, because now it's overclocked. Now I'm going to get back into the BIOS. So tag has been applied basically, and you're going to see it's at 4.5 gigahertz. 4.5 gigahertz, 2800 megahertz on the memory, all that goodies. And that's because tag was enabled. And actually tag is pretty cool. So if we go into the system settings, we should actually see the numeric values keyed in. Everything I did was keyed in. So advanced core settings, you see all that stuff is disabled. Uncore is at 40x, and this is all load optimized defaults. These were all gone before. Memory is still on XMP. Voltages are exactly what I set, so that's pretty handy. So now I've showed you all the OC features, most of them, if not all the important ones that you're going to use. Well, actually, I should have showed you the OC trigger switch. So I'm going to go out and show you how the OC trigger switch can work. So I'm just going to exit, save and exit, exit without saving, so that should just boot straight into Windows. Well, no, actually, it's going to restart it. So the OC trigger switch will change between high multiplier and low multiplier on the fly. And I'm actually going to blue screen for this because I want to show you how it works. I mean, heck, maybe we'll hit a high speed, but I don't know. So Windows is booting. Sorry about the accent. Yeah, hard drive's a little slow. Anyway, so the voltage is here, right? 1.28. We have 45x. And now I'm going to show you how trigger switch works. So this is really, really cool what I'm about to show you, and how to get frequency world records. So we're going to zoom in once again. And I know I'm going to be like a magician. I'm going to show you there's no cheating here. So I'm going to put the mouse cursor right there. Okay? Now, OC trigger switch, I'm going to engage right now, and everything go to 800 megahertz. Okay? And as you see, Uncore also goes to 800 megahertz, the Uncore frequency, right? Now I switch it back, and this should go back to 4 gigahertz, yep. And this should go to 4.5 gigahertz, yep. Okay, now watch this. So you know I had the multiplier up and down, right? So I can go up to 46x, right? But let's say I don't know how stable I am there. So I hit trigger, I go back down to 800. I'm going to press up one more time, and that should take me to 47x when I hit it, okay? Yep, 47x. Now I go back down. I could hit F7, save the validation. Now I press up again. We're going to go to 48x, and we're going to go back down really quick. Now I am counting on blue screening here. So this is just to show you how far and how you get the world records. 48X. You saw that, right? Now press one more time, and this should go at 49X. Yep, back down again. Now we should go to 50X. So I can change the multiplier without actually changing the multiplier. In real time, I can change it, and the system knows to change it, and now I should go to 50X when I re-engage trigger. Yep, 50X. So I went to 5 gigahertz on the same voltage. Now I want to press one more time and go to 5.1, hopefully. Nope, blue screen. Well, not blue screen, the system, yeah, blue screen. Cool. So, ladies and gentlemen, I think I've showed you what this board has to offer. Oh, and the trigger switch is this one right here. And we can just restart. Sweet, right? And CBAT, watch CBAT. So I'm going to hit CBAT right now. System totally shut down. OC ignition still engaged. I'm going to disengage OC ignition. But watch. CBAT's so strong I can't power the system up. I can't. I can only power the system up if I remove the 24 pin and put it back in, because CBAT's very powerful. So this is the normal clear CMOS, but that's CBAT down here. So if I put this back in, okay, and now I press, everything starts up fine. Alright, cool. I press CBAT again, power drain, still can't start up. Remove 24 pin, put it back in, I can go up and down. But clear CMOS is different. So clear CMOS, if I hit it, it's just going to clear CMOS and reboot. If I power down, let's power down. Okay? Well, it doesn't want me to power down. Okay, go into the BIOS, tell me. Okay, system power down. Now if I hit clear CMOS, it's just going to start me back up with the fresh CMOS. But remember, CBAT's going to drain. CBAT drained. Okay? So be careful with that. CBAT's a very powerful tool right here. And great engineering by Gigabyte on their part. Alright, thank you for watching this edition of Tekken 10 with Sin. I hope you enjoyed it.